What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to look at tree diagrams, and this is an introduction to this topic, and we're going to look at it again in the next lesson. So tree diagrams are just an incredibly good scaffold for us to use in order to get multi-stage probability questions correct. I know we've already looked at how to solve these just using multiplication, but sometimes being able to visualize the information that's been given to you will make a huge difference and really help clarify things for you as you move through these questions in an exam. The best thing about tree diagrams is they account for all of the variations that could happen in a probability question. These are things like with or without replacement that we talked about last lesson, or potentially equal versus unequal kind of representation or probability within a question. We're just going to look at equal probabilities for this one, and we're looking at unequal in the next one. The other thing that's really important, and this is what I find the hardest, so these tree diagrams always help me out so much with this, and that is, does the order of the events actually matter? So for example, if you flip two coins and you just had to get ahead to win, that could be different to getting ahead first and then getting the win. So these two things are a little bit different, and the tree diagram will let you just read off the answer, no maths at all. So the big pro tip for these is if you do the setting out correctly, and you have to take your time while you do this, if you do this right, you don't have to do any maths. You just have to read off what you've already done, and then you'll get full marks. So please have a ruler ready for this one and leave some space on your page if you're going to write the notes out. These two things, space and neatness, will determine whether or not you do well in this topic. So we're just going to have a look at an example. We've got 3 marbles in a bag, one red, one green, one blue. What's going to happen? We're picking one out at random, looking at it, writing down what result we got, and putting it back into the bag. So this is a with replacement question. So we're going to really focus on how to draw these for this example. So the first thing I want you to do is start with a dot. This is you getting ready to do the experiment. And now, because we've got 3 options, red, blue, and green, we need to draw 3 lines coming off our dot. This is where having a ruler is super important. If you rule these lines to the same spot or the same vertical length, you're going to find this super easy. So that's our first step. 3 lines, done. At the end of each line, we've got to write down the outcome that could have occurred. So we could have got red, green, or blue. So we're just going to write RGB at the end of each line. So the line is kind of the branch saying, hey, we started here and we could have gone to any of these situations. These could have happened. So this now is the sample space. Red, green, blue is the sample space for the first step of this multi-step experiment. And now I want you to imagine that we've already pulled out the red marble. So we've pulled it out, definitely got a red, but we're doing this thing twice. So now I know that I'm at the red part of the tree. So now if I do the experiment again, I've got 3 options. I could again get red, blue, or green. So I have to draw that onto my tree diagram. I've got 3 more branches coming off of each single marble because potentially I could have got a green or I could have got a blue. So from here, your tree diagram is going to go from 3 branches to 9 branches. And again, we want to write out the outcomes that could have happened off each branch. So this is just going to be a repeat of red, green, blue, red, green, blue, and red, green, blue. So the big pro tip to getting these correct is try to line up where you write the outcomes, the letters that we used. If you can line them up vertically so they're in a dead straight line, you're just going to have no issues with reading what you've actually done. So this is just a really helpful kind of gauge to see if you're on the right track, and it'll just make sure that the maths you need to do is really easy to read. 2 other things that'll help with this is please try to use even length lines when you draw them. If you can have that in your head as you're drawing the lines, that'll help you out. And I always run into the problem that my last branches, because I've got 9 instead of 3, I kind of run out of space. So if you can just do your writing a little bit smaller, that might help you out and really help scaffold these well. So the way that we read these is if we draw a line on the outcome that we did get. So for example, here, if I throw a green line going from what I got, pulling out a red that first time, I'm definitely from the start up to here. Now I could have got a red the second time. So I'm going to continue to draw that green line from red to red again. What I want you to do every single time you do one of these questions is write out the outcomes that you could get if you followed this path. So for this one, it would be R. But I obviously didn't have to draw a red that second time. I could have got a red the first time and this time gone across to get a red green. And again, I want you to write that outcome down. And now if we keep doing this, I got a red and now this time instead I got a blue. If we write that down as well, we're going to see quite quickly that we are getting a sample space of what is possible in this experiment. So you just have to keep going and going and going. You don't have to draw the line every time. Obviously that's silly. This is just kind of showing you what I'm doing in my mind. I go across to the green and then red, blue, or green again, and I write down the outcome at the very end. So this list that we've written at the end of our tree diagram represents the sample space or all the possible outcomes. So if we did this experiment, there are only 9 outcomes that could happen. Right, we couldn't have pulled a yellow marble in this example. These are the only 9 physically possible. So for this first question, I could have something like, hey, what's the probability that you get at least 1 red? So that means that 2 reds counts, and red first and red second also count as well. So this is where the order kind of makes a little bit more sense. All you've got to do to get this right is count out the outcomes that have an R in it. For this one, there's 5 of them. So the answer is 5 divided by 9, done. So no maths involved, just counting and a little bit of drawing. Another type of question was, hey, what's the probability that we get a double? So red, red, green, green, blue, blue. We can see that there are 3 of these outcomes out of the possible 9. So I just have 3 over 9, which is equal to a third. So what I really want you to take away from these questions is that they help out with the order massively, because you don't have to kind of work out, oh, I had 3 red first plus reds the second time, so that would be 5 in total. Instead of having to do that hard thinking, you just have to count, hey, where's there an R? Bang, that's one of them. So it really, really helps out with these order type questions, and I think you will find them really useful. So the second type of these questions are the without replacement. So this actually becomes a little bit easier. The thing that we really need to make sure we're on top of is that the second branch, after we do that first one, this is going to be different because we're not replacing the option for the second go round. If anything, this is going to help you out because it just gets rid of having as many branches for that second step. So you might have a bit more space to operate with, but still, neatness and space are your best 2 friends. So this is almost the exact same situation, but this time it's with M&Ms instead of marbles. So we're going to pick one of these out of the bag, 1 red, 1 blue, 1 green. We're going to look at it, record the color that we get, and then we're going to eat it. So it's not being replaced. So for this one, we're going to start in the same place. We're putting a dot down and we've got to put the possible outcomes for the first experiment down. So because there are 3 possible outcomes, red, blue, and green, that means I've got to draw 3 lines that go to the exact same spot on the page. We want to line these up immediately if possible. Again, at the end of the lines, please write in the outcome, red, green, and blue, and then we're going to go from there. For this one, I want you to imagine that we got a red. That's that line there. So if I got the red M&M and then ate it, in your mind, think about what would happen in the next stage of this experiment. I couldn't get a red then. There's only 2 M&Ms left. One's blue, 1 green. So instead of having 3 lines for the next one, I've only got 2 outcomes that are possible. So I only have to do 2 branches. And this could happen as well if you've got a green or a blue. It doesn't matter. The next stage of this experiment will only have 2 options because you've already eaten the first one. So all I have to make sure that I do is that I write the other 2 outcomes down. So a really good check for these ones is if you've written R and now that's gone, make sure that you've got B and G coming off. So again, please just notice how I've lined these up vertically. It is the most important thing. Boys especially do struggle with this. So if you line it up, I guarantee you'll get the mark. So again, we're going to write the possible outcomes at the end of each branch. So I've got red, green, red, blue, green, red, green, blue, blue, red, blue, green. Again, very obvious that we can't have a double up here. So instead of having 9 outcomes like we did in the last one, we've only got 6 this time. Again, this is helpful because now when we do probability questions, we know that the question has to be over 6 because that is our sample space. If I asked you what the probability of getting a green M&M was, all you have to do is count up the ones that have a G in them. There are 4 here out of the possible 6, so my answer is 4 over 6, simplified to 2/3. You're most likely going to get a green one. For this next one, the order matters. What's the probability that I get a blue, but on the second go? I've only got to count up the ones that have a B at the end, which is 2. So my answer is 2 over 6. This simplifies down to 1/3. Done. That's all you've got to do. So I hope there you can see how it helps out with the order straight away. You don't have to do any kind of working back or logic to work out what the answer is. You can just read it off the page. So I know that this lesson is not very heavy on maths. It's really just about going slow and setting out correctly. One of my students has said before that, hey, this isn't really like a maths lesson. It's kind of like logical art. If you do the drawing correctly and take your time, you can just read the answer off without having to do anything. And I actually think the term logic art is quite nice for this topic. If you do the drawing well, you'll get full marks. You don't have to be a great mathematician in order to excel in this topic. Thanks so much for watching, guys, and I'll see you later.